Hello, today I'm looking at battery monitor. Now this is the Junctek model KH110F. This is a 100 amp shunt unit, nothing on the end. So let's open the box and take a look at what's inside. Inside the box we have a quick guide. We've got 3 boxes including the display module there and some cables. Let's get it all out on the bench. So here's all the stuff that was in the box. You get this huge long cable which links the display unit to the measurement unit, and you also get a shunt unit here. So I'll just open this up. You just remove the lid, and inside is this is a 100 amp unit. It probably only measures up to 100 amp, but this says 200 amps, 75 millivolts, M8 bolts here. You don't get these connectors, but I put them on because actually they work with banana plugs to plug in like that, but it didn't work terribly well, so I'll probably use 8mm ring terminals. Bag of cables here, I'll go through those now. There's this cable, 4 wires, which links the shunt to the measurement unit. There's this cable, 3 wires, which just has bare ends. Now that's for the relay control output. Relay is not provided, you have to provide your own relay. You get this 2-wire thermistor, and you also get this connector which goes into this socket, and that's to power the measurement unit. Now I've already attached a wire to that for some experiments, but yeah, that's everything in the box. So the first thing to do is to power up this voltage and current measuring module. So we put now there's 2 ways to power this. You can either power it independently of your battery and load and measurement system, or you can tap off from your battery and power this from the battery. Now I'm going to do that just to make the wiring a bit simpler in the first instance. Now I'm going to use this lithium iron phosphate 12 volt 4-cell battery. I was using this lead acid 12 volt battery, but it just depleted so quickly it was next to useless. So yeah, I'm going to use this one. So I'll put that behind my mat, and then I've made up this. So I've got some banana plugs to go into the battery and some outputs to go to my load, or to go through the current shunt and then to the load. But I just did a tap off point here where I'm going to connect this thin cable, and that goes to the plug which will enable the measuring unit to be powered from my 12 volt battery. Okay, so let's plug in positive into this unit. So that goes into V-sense. So that's actually the measuring input, but if you set this to the 2W setting, which you can see it's set to, you can use this in 2-wire mode. You don't have to separately power this. But then of course it can only measure down to about 10 volts, because any lower than that and the measurement unit isn't getting enough voltage to operate properly. If you separately power this box from an external power supply, you can actually get this unit to measure all the way down to 0 volts, although with most batteries of course you really wouldn't want to do that. So now I need to feed ground here into the ground input, but actually you can feed it in via the current sense module. So let's connect that next. So the current sense cable is VCC ground, iSense positive and iSense negative. So plug that in there and then connect that to the current shunt like so. And now if we connect battery negative to the battery side of the current shunt, I'll take off that connector, we'll complete the circuit for powering the measurement unit. So I'll just undo that nut and take off that connector. So I put a 8mm ring terminal on there. Now if I connect that, the measurement unit powers up. Just need to get a good connection on that. And you can see that the measurement unit is working because the run light flashes on and off. Okay, so that's that unit powered up. Next, let's connect the display module. And that's nice and easy. You connect it to the display port here. Now we've got a BA. This is an RS485. The connections are BA, ground, and plus 5 volts. So you can't really get this one wrong, but this is a huge cable. I think it's about 3 meters long. So I'll just get that in a suitable place. And then if I connect the other end of that into the display module, you can see that it says, oh, I didn't click it in properly. Connected, Junctek, whatever the model is, and this powers on. So essentially, what does this unit do? Well, it measures voltage, which it's already doing through this little thin wire. And it doesn't matter that that's a thin wire because this thing doesn't draw much power. And it also measures current, which it does through the shunt. Now that's currently 0 amps. But if I put a load on here, and that's the next thing I have to set up, we should see some amps appear on there. And of course, once you've got volts and amps measured, you can also calculate watts. And then it does the time-based derivative stuff, amp hours, watt hours, and all those sorts of things. Right, let's use some blue tack on the bottom edge of the display. And then I can stick it there in such a place that we can see it and hope that it won't move. Okay. Now you can also get a temperature measurement using the supplied thermistor. I'll just plug that in temporarily so that you can see the number appear on the display there, 22 degrees Celsius. You can have that in Fahrenheit if you insist on that sort of thing, but I'm not going to leave that connected because it's just adding to the clutter. And the only thing really that's useful for is there are some shut off parameters, and you can have, I think, over temperature and under temperature disconnect. You do need the relay for the disconnect features. I'm not going to do the relay in this video. I'll just keep this to the simplest setup that I can fit on my desk. Okay, to see some current, we need a load. So I'm going to use this bulb. So I've made this little base so that that can sit in there. And then I need to complete the wiring. Here's positive, so I'll put a banana plug in there. And then negative needs to link back to here, so I can use a double banana plug for that. So connect negative of my load into the shunt. Now the bulb's not very bright because it's a 24 volt bulb on a 12 volt battery, but there we are. We've got 13.06 volts, 0.68 amps, and watts is 8.7 or thereabouts. Right, let's quickly run through what's on the display here. So volts, amps. If you're discharging the battery, amps shows up in blue and you get dis there. If you're charging the battery, amps shows up in green and you get CHG there. Watts is derived from volts and amps. Now you've got a state of charge of the battery. Now this is not voltage based. This is a coulomb counting state of charge indicator. In fact, this unit doesn't even have a setting for what type of battery you're using. So NMC, lithium iron phosphate, or even lead acid, this doesn't really care. It does state of charge purely by counting down amp seconds or amp hours. Amp seconds, of course, are coulombs. So this is a coulometer. And I'll show that working. Although my battery is actually 12 amp hours, I've set this to 1 amp hour so that we can see it count down the amp hours. You can see it's 0.996 amp hours. So it's set to 1 amp hour. I've told it that the battery is completely full. Let's connect up the load. And the other thing on here is a clock, a real-time clock with date and time, but it's not actually running until you set it. But what you can see is that the amp hour number is clocking down. So 0.994, and then any second now, yeah, it's gone to 0.993. And the state of charge percentage indicator will also start clocking down. So there is an internal seconds counter which is running because it's providing the coulomb counting, or not quite coulombs, but amp hours are counting down. It's amp hours to 3 decimal places. So letting that continue to count down, this time left indicator is also a time-based field which looks at, it takes a while before it comes up, but it looks at the rate at which it's counting down in thousandths of an amp hour, and then eventually it will give you an hours and seconds remaining time indicator based on the speed at which the remaining amp hours indicator is going down. So I'll just leave that going for a while. I'll speed this section up. Okay, so that field has now appeared. It says that we've got 1 hour and 25 minutes time remaining, assuming this battery was 1 amp hour. It's actually far more than that. And you can see now we're down to 0.953 amp hours and 95% battery remaining. So this does real-time voltage, real-time current, real-time power. It also does remaining amp hours and state of charge as a percentage, remaining time. And then the other field here is just says record, and it's currently paused, and you can't actually make it record if you haven't got the real-time clock set. I suppose because what it seems to do is act as a data logger, and I think all the information is actually stored in this unit. This must have some memory in it. And it seems to log voltage and current, and also time and date information. The default for this is that it records 1 sample per second, but you can slow it down. Although even at 1 sample per second, it seems that this has got actually quite a bit of memory. So in order to get that working, I'll have to put my hand around the back. I want to go into the settings thing here, and you can go through pages of settings here. So settings, second page, third item. If we go in there, you can see that it says that the record system is on, but it's not counting up. That number there, the count 3225, that's a count from previous experiments I was doing. So it's not actually running, and that's because the real-time clock has not been set. Now there is a setting for setting the real-time clock. Oh, I think I need to come out of there. Let's leave that on. Come out, go back to the real-time clock setting, which is here. And there is a torturous real-time clock setting process. So I can go up to 2001. Let's go up to, I don't know, 2010. I think I have to, yes, that's now started the real-time clock running. And now if we come out of settings, you can see that the record indicator is no longer paused. It has a play indicator, a little triangle, which I think is rather odd. I would have thought that would be better as a little red dot, because it's recording. The question then you ask yourself is, well, how do you play this back? And that's when you have to turn to the app. Now here's the app. It's KH110F. Now in the manual it says download an APK file and install it. But actually I found that this was on the Google Play Store. So I installed it straight from there, and this is kind of what the app looks like, but it's not currently connected. So let's do a search, and it's this unit here, BTG008. I'll see if it connects. Sometimes it doesn't connect first time round. Oh, it has. And now we can see the data. We've got 12.95 volts. Does that match that? Yes, it does. 0.67 amps. Watts, amp hours remaining. It also does cumulative charging energy in kilowatt hours and discharging energy in kilowatt hours. We've got the state of charge percentage indicator there. We've got the estimated time there, temperature, the sensor's not fitted. And here's the data recorder, and you can see the little triangle there, which means it's in recording mode, not paused mode. You'll notice the other thing that's happened is that the date and time, of course, on my tablet is correct because it's on Wi-Fi, and it's transferred that over to this unit. So the easiest way to set date and time on this unit is to run up the app. Now, if I go into the settings, set, second page, third item, you can see here that the counter for the samples, and you can see that it's 1 second per sample and it's on, in other words, it's recording. The counter is now incrementing. It's done 3,404 counts. But on here, you're thinking, how do I actually view the data? Well, you don't. You have to go to the app and you go to curve, which is the second page. You can actually just scroll this left and right. So you can scroll to the second page. Now you've got real-time voltage and current curve here, and that's obviously coming over the Bluetooth. Incidentally, there's nothing on here that shows you Bluetooth is connected, but you do see it on this light. Rather than a 50% mark space on the run light, it's now a sort of flickery run light. So that tells you that the Bluetooth is connected. If you then go to the historical curve, switch that on, it will say that this will briefly interrupt the data recording, and you just have to accept that that's the case because it's downloading all the data over Bluetooth from this module, which has a Bluetooth module in it, to the app. And now we can look at the data on this graph on the app. And if we go to custom view, there is a delay on this app. We have a whole series of dates. That's 2023, June the 6th. So that's yesterday, actually. So if you want to look at today's data, it'd be easier, quite frankly, if I cleared all the data here, which I believe I can do in the app. You can also do it on the unit itself. I will have to try and work out how to do that. I'll do it on this module, actually. If I press that and go over to clear and press OK, it says clear and set. So you set the seconds per sample. So I want 1 second per sample. You can slow this down, but you can't go any quicker. I'm going to say OK, and that's now cleared all the data. You can see the counter's gone back to all zeros, 5 or whatever it is. And so it started again. If I now go back to the app and say historical curve, then it gives you that warning that it will briefly interrupt the data logging. If we now go to custom view, did I press it? The feedback is yes, there's only one entry now. And if I look at that entry, okay, I wasn't pressing confirm, so I'll press confirm there. And then we get to see a graph of the historical voltage and current data that's in the memory of that unit. And if we go back, we can again look at the real-time voltage and current data. If I temporarily disconnect the lamp, we should see the current, which is in green, fall to 0. I think the current's so tiny you can barely see the step there. So the essence of this unit is voltage and current measuring, and therefore power measuring, state of charge indication, remaining amp hours, and state of charge as a percentage. But you do need to tell this unit how big your battery is. So this won't ever be precise, and it will drift, and you will periodically need to reassess that. And then the other thing is data logging. It does seem that it can store quite a lot in the memory. If we go back into that data logging thing, you can see that it's done 109 95 counts. Now previously I got up to about 3,000 counts, but it looks like you can get up to, well, almost a million counts. It would be 999,999. So if that's how much memory it's got in it, that's quite a lot of data. A million seconds. What's that in days? Okay, 694 days. So that's a couple of years of sample data, assuming it can go up to a million. I don't know whether it does, but if it does, that's 2 years of data with 1 sample per second. Now I'll just quickly go through the other setting entries. You've got set date and time. That's best done through the app. Language, Chinese and English. Sound on or off. There's a not very loud beep. Celsius or Fahrenheit. This is where you set the amp hours of your battery, so you need to tell the unit how big the battery is. This is where you set in the initial state of charge. You have to estimate that, of course. You can set a screen brightness for daytime, a screen brightness for nighttime. You can set whether the screen goes off after a period of time. You can set up the Bluetooth password. This is the data recording screen that I was on before. Protection, delay time. Now this is all to do with the relay. I'm not going to cover that in this video. I might in a subsequent video. Zero current memory. You can, if you've got a residual current showing up when there's no current flowing through the device, you can zero it out there. Relay mode, you can either have normally open or normally closed. The address of the screen unit. A reminder that you're getting to low capacity on the battery. It'll probably beep. And here are all the protections: over voltage protection, low voltage protection, charge current protection, discharge current protection. And all of these require that you attach the relay to the measuring unit so that it can cut off if any of these is triggered. Over temperature protection, low temperature protection, protection recovery time. So you can get it to disconnect the relay, but then if the conditions settle back, you can have it switch the relay back on after a period of time, which you set there. Display host mode, where you can actually stop it talking to the display. I don't quite know why you want to do that. And a factory restore. And those are all the settings. And just looking at the 4 sections of the app, you've got the main page there. You've got the ability to look at current data and historical data. You've got settings. Now I've noticed here there's a firmware upgrade. So you can probably pull firmware into the app and then have it transfer it to that unit. So I assume you can upgrade the firmware of that unit. Have to have a look at that in another video because this one's probably getting very long. And there's an about page. And so that was an initial look at the Junctek KH110F and a little run through of some of the settings. And if anyone's interested in more detail in this, I am going to, this will appear in another video coming up fairly soon because I'm going to use it to test the capacity of a lithium iron phosphate battery from fully charged to fully discharged. So we will see this again in a video pretty soon. But that's it for now. Cheerio.